Assalamu alaikum wa rahmatullahi wa barakatuhu. Friends, welcome back to my channel. In this video we will discuss how we can prepare a DSO, digital storage oscilloscope, or any oscilloscope to measure voltage and how we can set the oscilloscope properly. In this session we will cover the probe setting and the coupling of the oscilloscope. Basically, I received this message from one of my viewers. He purchased a new oscilloscope. Dear, I buy new DSO Unity 2025. Congratulations. Can you make video on ground coupling? So let's discuss. First of all, when we discuss oscilloscope have two channels, channel A and channel B, channel 1 or channel 2. Oscilloscope probe, DSO probe, it have one input terminal, the high input terminal or signal probe, and ground tip. It is similar to a digital multimeter probes, high probe, low probe. So this is low side and this is low side, and this tip or this tip is similar. When we connect to measure any signal, we must have to connect this grounding pin to the power supply ground. Here we have power supply ground, so we will connect it here so that the signal must have a reference point. Now it is getting ready. Check this probe. It have here attenuation selection 10x and 1x. This 1x, when it is set to 1x, so the signal applied to the measuring tip here will directly applied to the filter, sample and hold circuit, processing circuit, and this same signal will proceed to the display. But if we will set it to 10x, at that time this probe, it have a attenuation network, it have a voltage divider network, that is 10 to 1 ratio. So the 10 volt signal here will be attenuated, will be downgraded to 1 volt, because here we have a ratio 10 to 1. So 10x, 10 volt signal will provide it to the scope 1 volt, and if we will connect to 1 volt, so that means it will give 100 millivolt. If we will connect this probe to 100 volts, it will divide by 10, so 10 volt signal will go to the oscilloscope. Similarly, if we use 10x, 50x, 1000x, 500x, 5x probe, different attenuation values are available. So this probe, it is 1 and 10. When we will set to 1x, if we connect it to 100 volts, so 100 volt signal will pass to the oscilloscope. And if we will set to 10x, it will attenuate to 10 volt. So this oscilloscope will get a higher range and this circuit will in safe range. When we use a new probe, we have to connect to a reference signal. We have to calibrate it to read the same reading at 1x and 10x. When we will connect this signal, okay, I will discuss next time how to calibrate this probe. Now I will connect this probe to this signal, and same we will connect to the same point. So I connected both ground terminals to the power supply ground and both signals to the same test point. Now we have a auto set button here. Now it displayed two signals, a yellow color signal that is at channel 1, and there is a yellow marking on this BNC connector and a blue marking at this connector. So blue signal for this channel B probe. Channel A is yellow type, and here is also yellow and green marking on the selector buttons. This time both signals have same value, same amplitude, same rise time, same fall time. I will select channel 1 and we will compare the both signals, channel A and channel B. I will select channel 1. In channel 1 option, the first segment that is here in the first soft key, that is DC, coupling DC. I will press this coupling to AC. We can see the yellow signal, that is channel A signal, is now dropped down. Its offset level is dropped. It is showing in the same range because channel B have coupling DC, but channel A have AC coupling. Why this happened? We will discuss on the paper. If I will select to ground, this was the question of my friend. When we will select it to ground, this time this oscilloscope will not detect any signal from channel 1. Okay, back to DC. So it is giving the same signal which we applied. Selected to AC, the signal value dropped to some lower level. But if I will raise the offset level, it have the same amplitude, but its DC offset is dropped. If I will revert back to DC, now the level is raised up. Set back to AC, it will shift the offset level. Why it is happening, we will discuss. And at ground point, we can see how much the offset level increased. So this is the ground level. Let's discuss why it happened, and then we will check a DC signal for more clarity. We have this circuit which is providing a test signal. Here is high side signal and this is ground. We have a probe here, test probe, and this is oscilloscope ground line which we connected here to the power supply ground. So we connected this ground to this one. So both grounds, power supply ground and the circuit ground, is same. Now if we will connect to 1x, this 1x signal, so it will connect it directly to the scope. And if we will select to 10x, at that time it will take 10 to 1 ratio, 9K 1K. So it will take 10 time attenuated signal. So it will drop 9 volt and it will just give 1 volt to the oscilloscope. It is attenuation function. Now the second thing, that is coupling. When this signal is entered in the oscilloscope, here we have 3 paths here. The first path, that is DC coupling. It is just only level sense circuit, and from level sense circuit, amplitude sensor and sample and hold circuit, this reached here. Then the same signal is applied to a capacitor and it reached here. Then there is a third option, that is ground option. Here we have DSO input circuit, that is the inside oscilloscope. This circuit, it is also inside, so it is coupling circuit. If we select DC coupling, it will connect here. When we select DC coupling, the DC voltage containing any type of DC, AC, pulsating DC, any component of any type of signal will pass with DC voltage. Either it is DC, either it is AC, anything which is coming here, it will directly pass to the sample and hold circuit and to the processor. And if we want to test a purified signal, that is AC signal, and we don't want to enter any DC component, any DC voltage to the scope, so we have to pass through the capacitor. When it will pass through the capacitor, so it will couple here. So at that time this signal, this line will disconnected, and now all signal entering to the oscilloscope will pass to the capacitor. And when we select to the ground, it will disconnected, and the sample and hold circuit and processor will connected to the DC coupling, the ground coupling. So oscilloscope will show 0 volt. So this is the coupling function. Now I will connect channel 1 to the DC voltage, that is here. Now we can see the channel 1, it is displaying 12.8 volts. The yellow signal 12.8 volts, it is here. And if I select this coupling to 10 time, we can see there is a visible change in the display. This is 1 time, it is displaying 12.8 volts. When I swap to 10x, the voltage is dropped to 1.28 volts, and the displays also dropped on the bar graph. So here we set to 10x and 1x. Now 1x, this is 10x. At 10x, this is reading 1.2 volt. Now if we set this probe to 10x and we take this measurement, that means we have to multiply with 10 to take the exact reading 12 volt. But we can set this option in the scope. The first is coupling, bandwidth, and then is probe. Which type of probe we are using at channel A? Click this soft key, 1x, 5x, 10x. I am using 10x probe. Now it is giving 12 volt. I set this probe to 10x attenuation and I set in the software, so it will display 12 volts. It will automatically multiply. So in this way we can verify, we can test the signal, we can monitor the signal. So the coupling function, that is basically which method we are applying to apply the voltage, from a DC filter or from the capacitive filter or from the ground. If we will connect to ground, at that time it will display 0 volt. For DC it will display AC signal, pulsating DC, or DC signal containing any type of noise, everything will displayed here. When we select this filter, it will just only pass the pulsating voltage, any type of voltage which have any change in the amplitude, which will pass from this capacitor, so it will sense and it will display. So it will stop the DC component. I hope so this video is informative. If it is informative, hit the like button. If you have any question, kindly let me know in the comment box. If you have not subscribed my channel, subscribe it. Thanks for watching. Assalamu alaikum wa rahmatullahi wa barakatuh.